All right, guys. So, as I promised in the beginning of the series, I'm going to show you guys how to make this so that his offset from the item is independent of his approach. And that way you can get somewhat good hand contact from any direction. And I'm going to explain to you in here how the math behind this works. And then I'm just going to show you how I did it in there. So I'm going to delete these because these were, I was testing different approaches to this. So right here, uh, this is this arrow right here, and I'll just actually go ahead and simulate it. This red arrow represents the forward vector of the actual item, and this blue arrow represents the direction to this location. The pink arrow represents the actual rotation of the entry point on our contextual animation scene actor, and the green arrow represents the starting position. So let me just explain to you a few things here. So when you inside of here, you'll see one of these will stay in place. One of these purple arrows will stay in place. And the other one, I'll be moving and rotating independently of the sphere. So none of these are children. That means they all, that means what the way that this moves right here, the way that this purple arrow moves right here will represent the rotation. It'll represent the entry transform rotation here. Okay. So let me just show you what it looks like in action. And so you'll see that the offset of that entry location is not based off of the player's forward vector. I actually created a vector that points from this item right here to the player, and it's based off of that vector. And so if I come over here, you'll see if I'm in the correct position, then the starting position and rotation will be exactly what it was in the contextual animation scene. But if I'm at any other point, then it'll be offset, you see, so that it's at a relative offset to it, which is actually what we want for the best hand contact. So I'll go ahead and break down the math here. So this right here was irrelevant. But this location and this rotation will represent the entry transform location and entry transform rotation, okay? That's what that represents. So those are the starting position and rotation of that transform. Now what I'm doing right here, and I have this commented too, so you'll be able to, I'll be able to explain it to you better over here as well. What I'm doing right here is I'm getting that original that original location, and I'm rotating it by a vector that's pointing from the item's location to the player's location. I'm using that I'm turning that into a rotator, and I'm rotating this by that. And I know that's kind of hard to understand, but you can think of it like this. So vectors, they don't just have a position in space. They also have a direction. Okay, they have a magnitude, a length. Their location is relative to something. So in this case, this item's location is relative to the world origin, whereas a relative position would be relative to something else. Its origin would be something else. So right here, what the inverse transform location does is it gets a world position and it turns it into a local position. So it's taken the world position of the sphere and it's making that local to this actor right here. And so if I select this sphere and you see this local offset, this is a local offset. This offset is local to uh, the scene root of this actor. Now, why did I do that? You might think, why didn't I just say, okay, why don't I just get the relative location of the sphere? Well, you can do that if it's an actor. But if it's not an actor, you can't get it because this is a world transform right here. This is a world transform. This is relative to the world and not an actor. And that's why I treated this the same way. So I got its relative offset right here. And we actually end up doing this inside of there too, and I'll explain to you why. There is a way to actually get this transform in relative space, but I chose not to do it that way, and I'll explain to you why here in a little bit. So yeah, so I got a vector, and in fact, you can think of this blue arrow as that vector that I just created. Actually, no, that's not true. This blue vector, you can think of it as a vector. Like, for example, if I subtracted this item's world location by the sphere's world location, it would give me this blue arrow. It would give me a vector that exists right here at this item's location, but it would be pointing to the sphere. And so if you get a subtract node right here, you can think of this. If this the result of this will be this pointing to this. And if you turn it into a rotator, then it just means that it's getting the direction of this, and it's just turning that direction into a rotation. I actually used that somewhere else too. We'll approach that here in a little bit. So now that I have a relative, well, right here, let me explain. Right. So this rotation, I'm just rotating this vector uh, by that rotation. So rotate vector, let me explain to you how rotate vector works. So let me just drop a sphere into the world, or I'll drop a cube into here, that's fine. And I'll set that to the world origin. So this is the world origin. If I drop another another cube into here, okay, it's bugging out and not letting me see the transform for some weird reason. That's really weird. Let me just restart this. I'll save it. Yeah, that's fine. Oh, it's because I was playing. Sorry. Yeah, so you can't do that when you're running the game. So what I'm going to do is I'm going to get this and I'm going to parent this to the other one. And so if I call rotate vector on this cube right here, if I just call rotate vector on this cube right here, As this rotator, I just enter some arbitrary number. Let's say I enter 90 on Z. Okay. Then that would basically be like this. So if I called rotate vector on this location, on the location of this box, and I used a rotator with 90 on Z, it would place it right here in the world. So if I called unrotate vector and I gave it a rotator of 90 degrees, it would rotate it in the opposite direction. It would invert that rotator and turn the positive 90 on the Z into a negative 90, causing it to be rotated negative 90. So that's how that works. So I'm getting that I'm getting a vector that represents the rotation, and I'm rotating that by this. And since this is a local relative offset like this, then I can add it back to the actual item's location, and it'll be a location that's been rotated around this item and instead of the world origin. So yeah, it's really confusing. I just figured this out today, guys. That's how that works. So yeah, nobody's ever actually taken the time to properly explain rotate and unrotate vector. It actually ended up being a lot simpler than what I thought it was. So as far as the rotation itself, what I'm doing is I'm getting now remember, vectors have direction in games. In vector math, vectors actually have direction. So I get the original sphere's location, and I get the new sphere's location, and I can get the difference between those two directions, and I can add that by using the combine. It's just like adding a rotator to another rotator. It's the add function for rotators. So I can add that rotation to the entry transforms rotation, for example, and it'll let me rotate that by that amount to keep it relative. And so if with all that in mind, when I show you this now, then it'll make more sense how this works. So I had to figure this out on my own, guys, and I really beat my head against a brick wall. I think I probably spent 6 hours trying to figure out how to do this. Because, like I said, I'm not strong at vector math, but I'm a lot stronger now than what I was. And I figured this out without watching any videos either. I just reverse engineering. I seem to be really good at that. So anyway, with that in mind, now I can explain to you how this works right here. So everything should be basically the same as I showed you before. I'll go ahead and kind of move over this so that you can pause the video to see if in case I changed something and didn't mention it. But right here, you'll see I'm doing things a little differently. And so I'm going to explain to you why I'm making all these decisions. So I'm actually calling the center a get center of mass on the item mesh. And now it does say that objects that are not simulated return 000 as they do not have COM, center of mass. That's not exactly true. So center of mass still works. I'm not sure exactly what they even meant by that, or maybe if it used to be like that or what, but it's definitely not like that now. So why am I getting the center of mass? So the origin of this is not centered. The origin of this, the way I did this in here, and so this may differ if you're not using my project and yours is set up differently. but this blueprint's origin is actually the handle, which is where he needs this to be attached in order to have it in his hand properly, which is why I did this the way that I did it. So the center of mass, you actually want it, the center of mass would be actually the center of the collision for that object. So if, in order for you to actually understand that, I'm going to actually need to show you that. Yeah, sorry. Okay, so if I come over here, so this is a static, yeah, okay, so this one is a static mesh. If I come over here to show simple collision, you'll see there's a box around this. Now the center of mass would actually be where the origin of this box is, which is dead center. It's dead center of the box, okay? And the reason why did I need a centered position? Well, because if I have an offset that's over here, for example, and it's relative to this, then I actually don't want to rotate it around this. I actually want to rotate it around the center. Otherwise, it'll be rotating like this instead of like this. You see, that's the reason why I made that decision. You don't necessarily have to make that decision. I think it probably makes it just a little bit more accurate, which is why I made a transform where the location was actually the center, where the location of the center of mass is, rather than the actual actor's location. But I kept the actor's rotation, obviously, because the center of mass has no. The center of, if I used the center of mass vector as the rotator, then it would be wrong, because it would be pointing, it would be a rotator pointing from here to here, but the items vector, the items forward vector is like this. You see, it's along the Y, so that would actually be slightly offset by probably about 5 degrees or so, which is why I didn't do it that way. So again, just like I did over here in this one, I made that world location relative to the item location. In this case, I made this entry transform location relative to that center of mass location for the item, and that's going to be our source relative relative offset. And then the same thing, I'm doing the same thing right here. I'm getting a vector pointing from the item's center of mass to the player. And that's our rotator. That's our rotation that we want to rotate this by. And that's going to be our target relative offset. And then I'm adding that target relative offset to the center of mass location. And then that's our target location for the move to. I'll explain to you this right here. So this is optional, guys, right here. This part right here is optional, but I'll explain it to you. It makes it a bit more accurate. So right here, actually, I don't need this. Right here, I'm getting a vector pointing from the actor to the item's center of mass. I'm using that as a directional vector, and I'm multiplying that by 1000, which gives us a, let me just do it this way. So if I approach this item right here, and I go into top-down mode, then what that does is it gives us a vector pointing from this guy right here pointing outwards, pointing to this guy. Okay. And then actually it's the center of mass, which is around the handle right here, but I'll just do it from here. So we end up with, so whenever we scale this out 1000, actually I'm going to need to zoom out. Then it does this number. So it'll be a position out here somewhere. Okay. And then what I'm going to do is I'm going to get the approximate eye height of the character, which is set as a variable. I'll show you that here in a minute. And I get that vector that's somewhere out there, and I move it up by his eye height. That way he's not looking. That way he's not looking at a slightly downward angle. He's looking straight forward. So that's what I'm doing right here. So I'm getting the worlds up vector. I'm not getting the items up vector. And the reason why is because the items up vector will be relative to the item. So if the item is on this side, its up vector might be this way. Or actually, if you go into relative mode, you'll see its up vector is actually this way. And its right vector is actually up. But if I were to rotate this 180 degrees, now suddenly his up vector is this way and his right vector is pointing down, you see? So that's why I get the vector up, which is a constant Unreal up vector. That'll be the world up vector. That's up in the world, basically. And I'm multiplying that by the base height to offset it from 0 upwards by that base height, eye height. And that is actually stored in the class defaults right here. And you can change that number to be relative. That won't be his true eye height, though. There's also a crouch eye height for when he's crouching. So those are just approximations of where the eyes are. You could actually get that from the actual skeleton, but it's likely a lot more performant to do it that way. Also, yeah. Anyway, so I'm adding that to this vector that was offset forward. So now this vector is offset forward and up, and now I'm getting the target location, which is our calculated. Oops. Oh, okay. I'm gonna have to restart this. Okay, okay. This is one of those bugs where you have to actually exit the engine and come back in. Let me see. Normally playing it will sometimes fix it. So if I calculate the offset, which might be over here, and I rotate that around here, then it'll probably be like right here. So this is the target location. And we're adding that vector to that target location. So that makes sure that from this target location, we're looking this direction and up. So that's how I did that. So right here, I'm just doing a interpolated focal point here. So I'm setting the focal point for the AI character so that he's looking in that direction, in this direction here. And that's what I'm doing here. So right here, I'm just clearing and invalidating that timer whenever the difference between his current focal point and the target focal point is nearly 0. Whenever it's nearly 0, that means that they're basically the same vector now, and we can just go ahead and clear and invalidate that. I'm storing a reference to that right here for that purpose. And that's basically it, guys. That's the alteration that I made to that. So, yeah, that's the one I'm going to stick with. So I'll probably keep this in the actual project and I'll clean it up. Obviously, that's insane. So, yeah, I'm going to clean that up and I'll see you in the next video.